the first one here, the first question is asking for true and false. And if you didn't notice here already that number one is A, actually, right? So all the questions, they were like that. The number, so number one is first, but number one is actually the first question, A, B, C, D, right? So anyways, so they're asking you here, if there are 17 equally likely events, then the probability of the first one occurring is gonna be 1 out of 17. All right, equally likely, what does mean? That every single event has equal probability to happen. So every one you're gonna have 1 over the n. The n is 17. So this is gonna be yes. All right. The second one, the area under the normal distribution curve is always positive even if the z is negative. What do you think? So for this one, for B, this is my normal distribution here. This is the 0. This is z, for example, -1. So the area is area, right? What definition of area is always positive? It cannot be negative. We good? So it's true again. B is true. All right. So C, the probability of any event E is the number between and including 0 and 1. All right. So what they are saying here, if I'm going to write it mathematically, this one, for C, they are saying the probability of any event E is always between 0 and 1. And this is one of the properties of the probability. This is the first property of probability. So it's true. All right. D, if an event cannot occur, so what's going to happen here? Its probability is 0. So this event is not happening. What the probability of not happening event? 0 is correct. So this one for D, how can you write it down? The probability of the empty set is going to be 0. All right, the empty set is that circle and with the line, right? E, if an event E is certain, what the meaning of certain? It's happening 100%, right? And the only event is happening certain is basically the universal set, or sample space. Sometimes they call it sample space, sometimes universal set. That's the box, basically, right? And this is going to be 1. So this is the universal set if you are doing the Venn diagram, right? The E usually is something in between here. So if the E is always between 0 and 1. The sum of the probabilities of all outcomes in the sample space is 1. Absolutely. This is the fundamental theorem of probabilities, right? So if I have probability of E1 plus probability of E2 plus, it's gonna be 1. The sum of all probabilities is gonna be always equal to 1. Are we okay with this? It's coming straight from the book, these questions, right? Now, for this question here, they are asking you to figure out basically the z-score, the standardize and compare the logic, right? So we have two distributions. They are both of them. Yeah, they forget to say something here. They should say both distribution are normal distribution. Well, you can standardize it, but standardize it is not going to be a normal. So you can, the only way that we can go to a normal distribution is by sampling. So if you have a distribution that is not normal, and you don't do sampling, then the result is not going to be normal, and therefore you cannot use the table. So here they forget to say that the SIT scores and ACT scores, both of them, they must be normal distributions. So once they are normal right now, yes, we can go from X values to Z values. And we are not doing sampling here. That's the issue, right? If we did the sampling, I don't have any issue with normal or not normal. I can bring it to normal anyway. Are we okay, guys, with this? So then, assuming they are normal distributions, this is gonna be the first one, the X values, the mean here for the SIT, right? SIT distribution. So the mean is gonna be 1518. The standard deviation is gonna be 325. And for the other one, the ACT, all right? I think the mean is 21.1 and sigma is gonna be 4.8. And this is X as well, right? So far, so good? Okay. So what we're gonna do for both of them, we wanna bring them to something that we can compare at the same time. So we wanna go to the Z-axis, where the mean is 0 and sigma is gonna be 1. We wanna bring it to standard normal distribution, right? So this is the Z-axis, the mean is gonna be 0 and sigma is gonna be 1. All right, standard normal distribution. Both of them are standard normal distributions. We good? Now, the way to do this, that's what we call standardized formula. So what is the standardized formula? The standardized formula is Z equals to the X minus the mean divided by sigma. And depend what mean you are using, right? So I'm gonna call this is mean 1 and mean 2. So depend what mean you're gonna be using, and that's gonna give you different values. So that's the general idea. We wanna bring it to the same standardized method, and then once they are standardized, both of them, I can compare the values. However, I cannot compare the mean of 1518 with another mean of 21, right? Doesn't make any logic otherwise. All right? Okay, are you with me, guys? Now, for the first one, they are telling you the ACT score for 17 has the Z-score equals to minus 85. Is it true or false? So let me go back here. I'm gonna start the A. So in order to get the Z-score for the A, again, the formula is gonna be Z equals to the X minus the mean divided by sigma, right? Are we okay? And because I'm using the ACT score, the mean is going to be 21 and the sigma is going to be 4.8. So if I do the calculation, I plug in 17 in here minus 21.1 divided by 4.8. Are we okay? Plug it into the calculator, and I think this is going to be correct, minus 0.81. 85, sorry. You can double check it, guys. Yes. Now for B, what we got in B, we got the ACT score 17 is relatively better than the SAT score for 1490. So I cannot decide yet unless I know already the score of 17 is going to be minus 0.85, but I don't know the score of 1490. And I think probably we should skip to C first and then go back to B. Yeah, the order is kind of messed up. All right, so I'm going to go to C. C is asking for the Z-score corresponding to 1490, right? So I'm going to do the same thing, X minus the mean divided by sigma. Because I am doing the SIT scores, I'm going to do the X, which is 1490 minus I'm going to take away 1518 and divide by 325. Can anybody do the calculation, please? I think it's correct, right? It's correct? Negative 0.09? All right, good. After approximation, of course, right? Everybody okay with this? So now I can go back to B because I have both scores, right? Okay? And I can tell which one is better. So which one is going to be the best? The one having a lower grade or better grade? The higher grade is the best, right? And do you see, if I'm going to go to B right now, this is my normal distribution, this is my zero. The SIT score, this is the Z scores. All right, so this is the ACT score, and this is the SIT score, right? The SIT score is very close to zero, it's 0 minus 0.09. And the ACT score is close to 1, which is minus 0.85. Of course, it's smaller, right? So this is, I can write it down, ZACT, this is ZSIT, and of course, which one better? The SIT score is better on average, right? You got it? So standardized compare, right? Okay, I hope this is clear, guys. I think done, right? Oh, there is a D. Sorry. So we compared the Z scores already. The SIT score of 1490 is relatively better than ACT scores. That's the D, actually. Isn't the same thing? Ah, they flip it. They flip it. That's it. I mean, C and D is the same stupid question. Oh, sorry, I'm not stupid. I'm recording. You got it, guys? Yes? All right, so let's go to number 3. What level of measurement? All right, so we are in A, by the way. That's 3A. I think the setup is wrong, right? So 3A, what level of measurement classify the data into mutually exclusive category in which no order, all right, that's what we are looking for, no order or ranking can be imposed. You don't have an order, you don't have a ranking. What's it going to be? Nominal. This is your data. This is a review. The data, it could be qualitative or quantitative data. So the nominal, the first one, you cannot order it. They are like colors, days, names of people, all right? The ordinal data, still names, is not numbers. However, you can order it, all right? An example of order, I know. How do you feel? How do you like it? I like it very much. I like it only. No opinion. I don't like it. I hate it very much. That's an order. They are all names. You got it? Okay. Then discrete. No, not discrete and continuous. I made a mistake here. Is not discrete, and I think I get the wrong chart. So the other two, they are ratio and interval, right? These are the four. Forget about discrete and continuous. So the ratio and interval, the difference between them is, what is it? Very good. The mean falls 0. Bless you. The mean falls 0. So in the ratio, 0 means it's 0. In the interval 0, it could be not, right? For example, for the date, 0 years, what does mean 0 years? It's not 0 that the day is nothing, right? So 0 years is basically that the origin where we start. And every culture, they have different 0 years. All right, the Christian, they have 0 years where, they start from Jesus. Indian, probably something else. Maya, they have different things. Muslim, they have different things. Jew, they have different origin. That's the different 0, right? So the 0 does not mean a 0. It's just from where they start counting. All right, so that's going to be the interval. Okay, so let's go back to this. So the first one would be what we said? Nominal, right? Sorry. What level of measurement classify the data? The rank, however, piecewise. Okay. Now, what they are saying, it can be ranked, all right, but the difference between two of them does not exist. So this is you can rank them. You can say better to worse, for example, but you cannot make a difference. Does not mean anything whenever you make a difference between two things. You don't get a number, right? So this is ordinal, right? C, what we have in C, what level of measurement allows for the ranking of data. So we are ranking the data here. A precise difference between the unit of measurement and also include the true 0. There you go. So this is the ratio, right? They say the true 0. Are we okay with this? All right, describe which one of the following describe the nominal data. All right, nominal data, again, you cannot order them. Do you see here on the second option, they say, oh, my first choice, my second, my third. There is an order there. All right, my first favorite, my second favorite, my third favorite, that there is an order. Although they are days, but still there is ranking. So that's the second one, is going to be ordinal. The first one will be the nominal data, right? Because there is no order. Okay, number 5. Determine which one of the following describe the quantitative data. All right, I think, no, I didn't have a quantitative. All right, what is quantitative data or qualitative data? Qualitative are names, quantitative are numbers, measurement. All right? Okay, the volume, is it measurement or not? Volume. Quantitative or qualitative? Quantitative. All right, the name of a material from which the container is made, that's names, right? Qualitative. There is no number, right? The shape, qualitative again. All right, so the answer will be 1 and 3, 2 and 3. So, yeah, you give an example, guys. 6. Okay, you were told that 4 students from a class of 20 were questioned for a poll about study habits. This would be an example of, all right, this is type of sampling, right? This is the type of sampling that you are supposed to know. Random sampling, you know what is random sampling? From everywhere. Systematic sampling, that means you have a formula every third, every fourth, every whatever. All right. Stratified sample. Stratified sample, basically you divide the whole thing in groups, and then you go to each group and make randomly selection. All right? So you have to rank them first. Cluster sample. What is cluster sample? Cluster is usually used for location, clustering. Whenever you are in the same location, that's clustering, right? Are we okay with this? So the classroom, what do you think? Clustering, or what it could be? It could be the other one because we select people, but it can be clustering because they are on the same place, right? As well, if you were a member of this classroom, there is another group which is called convenience sampling. What is convenience sampling, guys? You choose whatever convenient. So if it were your class and you are a member of the class, it would be convenient for you to select 4 of your classmates to do the poll. But this is not the case because they say from a class, is not your class. So the best choice would be here. All right, the best choice would be the clustering, right? We good? All right, so I think we made it here. Is there anything else? 7. All right, we are selecting a pollster randomly sample 161 Democrat, 145 Republican, and 118 Independent. I think you got the idea already. All right, and then whatever the idea is, we are sampling from the Democrat, we are sampling from Republican and Independent. So what kind of sampling is this? What kind of sampling, guys? Stratified, yeah. All right, so very good. So we divide them in group first. We divide them in group, and then from each group, we did a random selection, right? So that's going to be stratified sampling. Okay, next one. The following frequency table is given to you. Construct the frequency bar of the graph of the data, construct the relative frequency bar, and then construct the pie chart of the data. So you are constructing the histogram, the relative histogram, or the bar chart, and you are constructing the pie chart, right? Now, obviously we have the category, motorcycle, sedan, and SUV and truck, right? We have the numbers. So I don't think it's difficult here to make the histogram. Let me try to do the histogram first. So if I'm doing the histogram of this one, so this is going to be the motorcycle group, this is going to be the sedan group, this is going to be the SUV group, and this is going to be the truck group. Are we okay? And then I'm going to rise up the bars. So let me see. I'm going to reach to 62 maximum. So 62, there's 60 here. Half of it, 30. Divide by 3, divide by 3. And 0 over here. We good? So now, the first bar, you're going to rise up how many units? 13 units, right? So this is going to be the first bar. I'm going to go up to 13. 13, you start in the middle, please. So the bars, they're going to be starting from the middle here. Go to 10, above 10 a little bit, and then you go down, right? So that's the first one, 13. Everybody okay with me? Second one, you're going to go to 62, right? 62 is above 60. So you're going to go all the way up 60. And this is, let's assume 62. We good? The other one, 62 again. So we're going to go all the way to the same level. And the last one is 45. So 45 is 40, and between 40 and 50. And this is going to be your histogram, right? No problem. Now, if I want to do the relative frequency, I'm going to have to change. I'm going to have to add another table. So the other table that I'm going to add, 13 stays 13 here. And then the next number I have to add 13 and basically these two numbers, right? So let me, this, the sum of these two numbers, I'm going to put it right here. So 13 and 62 is going to be 75. And that's what I'm going to keep doing. I'm going to keep adding the new number. So if I add this and this, I put it here. 75 and 62, that's going to be 137. 137 and 45 is going to be 182. We good? I'm going to do the histogram again one more time. But this one is going to be the cumulative histogram, right? So the highest number, I'm going to go all the way to 192. So basically 200, right? I'm going to take this 200. Then the half of it is 100, half of it 150, 150, and 0 here, right? I'm going to start the same way with the motorcycle, sedan cars, SUVs, and trucks. We good? And then I'm just going to raise up the bars up corresponding to these numbers, right? 13. So the first bar is going to be up to 13. I know this is 50, so 13 must be very low. Right here. All right. The next one, 75. 75 is going to be halfway after 50. And after 75, 137. So 137 probably going to be somewhere here. It's not an exact science, guys. Most likely you're going to do this by hand, and you're going to have a multiple choice, and you have to pick the right choice. So literally, if you do this by hand, you can figure out which one is the right one. All right. And the last one, 182. So 182, probably somewhere here. And you're all set with the relative histogram. Construct the pie chart. All right, the pie chart again. So you want to figure out the angle, right? So the angle, do you know how to get the angle, guys? You need to have the total first. So the total is 182. Do you see it there? So the angle for each one of them, of course, you have to round it eventually later on. So the first one is going to be, that's the frequency, 13 divided by 182. This one is going to be 62 divided by 182. 70. Yeah, 62 is correct. This one, 62 divided by 182. And this one, 45 divided by 182. I need your help, guys. Say again. Oh, I forgot to do something. What did I forget? All right, I forgot to multiply by 360. That's the ratio. I need to multiply by 360. This one, you multiply by 360 degrees for each one of them, right? To get the angle. All right, so what will be the first angle, guys? 20, 25.7. All right, 25.7. You can round it to 26. The second one. So you do the second one, you do the last one. 122.6. 122.6. This is 122.6. And the last one is 45 over 182 times 360. 89. There you go. Is it 122.6, right? You're done then. So what you're going to do, you're going to take your circle. All right, let's do the circle again. All right, that's the circle here, 25, 26 degrees. I have no idea what is 26 degrees. 122 degrees. 122 is 60 and 60. 89 is 90. Okay, we can do the 89, which is 90. So this is going to be almost a 90. This is the truck. The other one, probably this way. Yeah, something like this, right? So this is 122, this is 122, this is 89, and this is 26. All right. So what we got at the beginning, motorcycle, SUV, sedan, and this is SUV. And that's you're going to be your pie chart. Are we okay, guys? Great. Not so difficult, right? All right, do you know how to do the tree diagram? Not the tree, the leaf, stem and leaf plot? Yes? No problem? Stem and leaf plot. So basically, you're going to go with each number and you put it here. This is the 1, this is the 2, this is the 3, 4, 5. Those are the 10s, 20s, 30s, and so forth, right? So for example, I don't know if they order them or not. Yeah, they usually order them. They put them in order. So this is annoying if you do it without a software. But anyways, so let's start with the smallest number. What is the smallest number you see there? 14, right? So this is 14 here. I just wrote it down. What the next number? 21. 21 is here, so I write 1. Is there any other 21? No. 22, so I write 22 here. 23. What's again? There are 223. I don't see the other one. Second row. Here. Yeah, it was hiding. 23 again. So if I see it twice, I put it twice, right? And that's it with the 20s, right? Let's go to 30. 31, I think. And then 32. There is another 30. Where is it? Oh, there is a 30, yeah. How nice. 30. So it can be 30, 31, and 32, right? What else? Yeah, I'm getting bored about this. You got it, right? 34. 34 is gone. Do we have 35? We have a 36. We have a 37. We have a 35. 35, 36, 37. 6 and 37. And I think there is another 39 or something. Yeah, 39 here. And then we go to the 40s, 40. And then 43, 42, 40 again. 40 again. And then 42. And then 43. I think we're done with the 40s. There is 51 and 55. 51 and 55. Oh, 48. All right, 48. It was here that we can add it up. We made it somehow. Okay, everybody okay with this? Number 10. All right, so whatever it is, this is the the blood pressure. Measure it in number. There is no 120.5. There is only 120. After 120, 113. They don't take decimals. Are we okay? So they are choosing whole numbers over here. Okay. So they give you the histogram. This is the relative frequency. All right, so what they are looking for, I think A is somewhere in the beginning because I start with the B. So A, where is A? Approximate. All right. So they are asking you, approximate the percentage. We are looking for the percentage of people that they have high blood pressure between 110 and 119. So between 110 and 119, that means this bar over here, right? And this bar, you can read the probability in here. So this is the probability, by the way, for A, the probability of X between 110 and 119. And this is going to be 0.35. Are we okay? We good? No questions? Now, for the next one, for B, approximate, 0.35, they ask for percentage, by the way, right? So if they say the word percentage, write it down in percentage, 35%. If they say probability, write it as decimal, right? For B, approximate the percentage again of the people aged from 25 to 40 had systolic blood pressure reading between 110 and 139. So between 110 and 139, that's we go up to from 110 to 140, right? So we're gonna cover all this area in here. So the high body, the tallest one, you're gonna be go to 35. The second one, you're gonna go to 25, and the last one, you're gonna be 15. So if we're gonna write it down here, so this is A, this is B. This is the probability between 110 X and 139. And this is going to be 0.35 plus 0.25 plus 0.15. We good? If we add them up together, that's going to be 60.75. Or you can write it down 75%. What they ask for the percentage again? Yeah, so 75%. Are we okay? So you have to add the 3 bars together in order to get that. Okay, let's go to the next one. C. What class width was used to construct the relative frequency, the width of the class? It seems like a 10. Yeah, I have a concern about this, but anyway, I think the numbers that you see here, the number 100, 110, they are the lower bounds. They are not going to put the lower and the upper bounds. I think so. All right. So the lower bound of each one of the classes. It means, according to my understanding, right? So I'm not sure that I'm. It means this one is 100 here, and you're gonna go all the way to 109. Are we okay with this? And this is gonna be 110. You're gonna go all the way to 119. You got it? So these numbers, the 100, 110, and so forth, they are the lower end of the intervals. And the class width is always the difference between two of them. So 110 minus 100, you're going to give you a 10. That's going to be your class width. Either 2 consecutive upper bound or 2 consecutive lower bound. All right. Are we okay, guys? So this is gonna be C. I can use 110 minus 100, and this is gonna be a 10, which is the class width. Identify the center midpoint of the third class. All right, the third class, where is located at? The third class is right here, right? This is our third class. And I want to be the middle point. So what's it going to be the midpoint? Although in the answer sheet is 125, I don't agree with that. So what the next class here on the bottom? What's it going to be? 100, 110. And the next one is going to be 120 to 129, right? Whenever we do the midpoint is actually taking these two numbers. It's not taking the vertical numbers. It's taking the horizontal numbers. So you're going to do 120 plus 129 divided by 2. And this is going to be giving you 124.5. I think it is 124.5. 125, that is not the midpoint. I mean, according to this table, is not 125. Because those are the lower, yeah. According to the formula and according to the table, right? Are we okay with this? So this was D. And find the class boundaries of the third class. Class boundaries, what is the class boundaries? Do you remember you take half here and half here? All right. So if I go here, the boundary on the right, what's it going to be? 129.5. If I go one boundary to the left, instead of 120, what's it going to be? What I have next to 120? Half point on the 119.5, right? So this is the class boundaries for the third one. It's going to be from 119.5 to 129.5. Are you okay, guys, with this? Yeah? Okay. 11. Yeah, 11 here, that's basically what they told you here. We have the mean here. This is the mean equals to 44,100. And the median is going to be 35,300, right? So usually the median is where you divide half of the data, right and left. This is the half. The average is tilted toward where the numbers are from, where the tail is. All right, let's put it this way. So first of all, I will suggest you to put this in the middle. And then if the mean is on the right, then the tail is on the right. If the mean on the left, then the tail on the left. So this one is most likely going to go like this. Right tail. Right tail means skew it to the right. Are we okay, guys, with this? This is the formula for skewness. Left and right, and as you see here, if I make my reference the median, forget about the mode. If I make my reference the median, it depends. If I am having the mean on the left, it's going to be skewed to the left. If I'm having the mean on the right, then skewed to the right. Are we okay, guys, with this? So grab the median first. After you grab the median, go with the mean, and depend what the direction you're going to give you from the mean. Oh, wow. All right, 12. 12A. Find the sample standard deviation. Obviously, I'm not going to do it by hand. We don't want to do it by hand. So let's switch. All right, so calculator part, how do you do this on the calculator? Standard deviation, you need the calculator for it. So what you're gonna do, you're gonna go to stat. Stat is right here. You're gonna edit. Hopefully it's empty. You're gonna put the numbers in. We have 23, enter, 27, enter, 12, enter, 17, enter, and 16, and enter, right? We good? And then you're gonna go to start again, and then you calculate, and then enter. L1 is the list, frequency, don't put anything in the frequency because only have a list. And then you do this one, and you get, do you see the X bar is equal to 19? I don't think it's 19, right? Do you get 19? Oh, that's the average, right? Yeah, standard deviation. So there is another thing I want to bring your attention to is the standard deviation here. They are saying sample word, right? So if they say the sample, which one of them I'm going to take? There are two standard deviations. There is Sx equals 5.9 and there is sigma x equals 5.3. Which one are you going to go with? 5.9 because S for sample. We good? You round as much as they tell you. So usually they tell you, or the multiple choice, right? So it's gonna be 5.95. I'm gonna keep it as 5.95, right? 96, 5.96. And this is gonna be the SS. B, find the mean, mode, median. You don't have to go really far away. You have everything on the calculator. You did it, everything. The mean, what is the mean? The mean, the X bar. Do you see the X bar? The mean is the X bar over there. That's the mean. The mode. I mean, the mode you do it on your own. So the mode, is there anyone that repeats? No, there is no mode. No, probably it should put no. The median, if you go with the arrow down a little bit, you're gonna see the median is saying 17 over there. The same calculator, right? So this is gonna be 17. And mid-range, what is the mid-range? Mid-range is gonna be maximum plus minimum divided by 2. So what the maximum there? I have the minimum is 12. And the maximum, again, you can use the calculator if you want to do 27. So 27 plus 12 divided by 2, that's going to be 39 divided by 2, which is equal to 19.5. Are we okay with this? Now, we did the mid-range. Okay, a student has an average of 20 on 6 chapter quizzes. So it has 6 quizzes and had the average is 20. And the other scores are above. They tell you the other numbers that you see there. What does this mean? That's his scores like that. All right, I'm adding an X in there. All right, so how can I get the average? The average is going to be 23 plus 27 plus 12 plus 19 plus 17 plus 16 plus X divided by 6, right? And this is going to give you a 20, correct? If you add all the numbers here together, I think I have them on the calculator. You don't have to sweat neither. So do you see the sum of X, the second line, sum of X, sigma X, that's 95, right? So this is all the numbers here are going to be a 95. This is going to be a 95 plus X. Cross multiply, you're going to give you 120. We good? So x, what will be? It's gonna be 120 minus 95, and this is gonna be a 25. Are we okay? The standard deviation of a set of data is 0. All right, what's the meaning of set of data of 0? If you have a standard deviation, you don't have a spread. What does that mean? Look, standard deviation is 0, correct? So what will be the spread? It's 0. So all the numbers, they should be on the same spot, on the same number. They are all the same. Do you understand what is it? So what this means, look, this is the mean here, and standard deviation is 0. That means there is no space to go out, right? So any number that you're gonna put, it has to be in here, all the numbers. I cannot put number here, because if I put it here, what will be the spread? Different than 0. So all the numbers, they must be on the same mean, right? Yeah, how many minutes I have? All right, 14. I'm going to do 14 really quick. So what you're going to do again, before going to the table, you want to array the table first. How do you array the table? I cannot see it clearly. There is a memory here, plus sign, second, and then plus. And that's going to give you access to all the memories. You want to go to clear all lists. All right? Once you enter again, you go back to statistics, edit, and everything is clear. Are we okay, guys, with this? Now, what you're gonna do, you need to figure out what are your variable x and what is the frequency. They are not the same. So what are the x's here? What is it? Is it the credit is the x's, or the grade is the x? Grade is the x. So the grade is the x, and then the frequency. 4 here, 0 grade, have frequency 5. 3 grade, you're gonna have frequency 3, 2, 1, 3 again, and 1 again, right? Are we okay, guys, with this? The credit here, the credit are the frequencies. So what I'm going to do, I'm going to go to my table. I have to put the x first. So the x is going to be a 4, enter, 0, enter, 3, enter, 3 again, enter, and 1, enter. Then I'm going to go to the other one. I have 4, 5, 3, 2, and 1. Now I'm going to go to statistic again. I'm going to do the calculation. Go to calc. First one, L1 is fine. The frequency, you have to type L2 in there. So how do you type L2? Second and 2. That's L2 already. You go down, enter, and that's going to be 2.13. That's what they are looking for, right? The average. 2.13. You made it.